Hi, I'm Kushagra Gupta and I'm presenting to you my ELP 101 project using OPAMPS to construct high-pass, low-pass filter circuits and voltage follower circuits. Here is a brief description about OPAMPS. The terminal 2 and 3 are the input terminals of the OPAMP. The terminal 2 is the inverting terminal and the terminal 3 is the non-inverting terminal. We take the output from the terminal 6 of the OPAMP. The power is supplied to the OPAMP using the 4 and the 7 pins of the OPAMP. The terminal 4 has the negative voltage and terminal 7 has the positive voltage. That's why it is an active device. Here are the most common configurations of op-amps, namely the inverting amplifier and the non-inverting amplifier. The voltage given in the inverting amplifier is given by minus Rf by Rn, whereas it is 1 plus Rf by Rn for the non-inverting amplifier. We can also configure the op-amps as a voltage follower. It acts as a buffer. We provide input to the non-inverting terminal of the op-amp and output is shorted to the inverting terminal of the op-amp. So the output is equal to the input and the voltage gain is 1. This was the description about op-amps. We also have RC, low pass and high pass filters which we designed using resistors and capacitors. But these passive filters have limitations such as the output is less than the input and there is a large attenuation in the input signal. The cutoff frequency can also get modified due to the input resistance. Similar to the passive low pass filter, we can construct a passive high pass filter using resistance and capacitors. The cutoff frequency is same for both the low pass and high pass filters. It has similar limitations as the low pass filter, so we construct active filters using op-amps. They provide the gain to the input signal apart from selectively passing the particular frequencies. The voltage gains for the low pass and the high pass passive filter are given in the figures. First, we realize the non-inverting active low-pass filter. The filter circuit is connected to the non-inverting terminal of the op-amp and output is taken from the output terminal of the op-amp. The op-amp provides a voltage gain AV depending upon the values of Rf and R1, which is given by 1 plus Rf by R1, and so the net transfer function is given by multiplying the voltage gain of the op-amp with the voltage gain of the RC low-pass filter. It is given by AV into 1 upon root 1 plus f by fc whole squared. Also, the cutoff frequency for the active low-pass filter is same as that of the low-pass filter. It is given by fc is equal to 1 upon 2 pi rc. Here is the frequency response of the active low-pass filter. It is similar to the passive low-pass filter. The cutoff frequency is same as that of the passive low-pass filter when the output is 0.707 times the maximum value. As we see, after the cutoff frequency, the response is limited by the gain characteristic of the op-amp, so the amplitude starts to decrease. When the input is coming from another circuit, we can either use a buffer or we can connect the capacitor to the feedback circuit in order to avoid the cutoff frequency being changed. Now, as we can see, this circuit also acts as a low-pass filter. The cutoff frequency is slightly modified as the resistance used in the cutoff frequency formula is Rf instead of R. When Xc is infinity, the voltage gain of the active low-pass filter is given by 1 plus Rf by Rn, and when Xc is 0, it is same as the buffer when the voltage gain is 1, since Vout is equal to V. In a similar manner to the active low-pass filter, we can now realize the non-inverting active high-pass filter. The filter circuit is connected to the non-inverting terminal of the op-amp and output is taken from the output terminal. The op-amp provides a voltage gain AV again given by 1 plus Rf by Rn, and so the transfer function is given by multiplying the voltage gain of op-amp with the voltage gain of the passive high-pass filter, which is AV upon under root 1 plus fc by f whole squared. The cutoff frequency is same as that of the passive high-pass filter. Frequency response of the active high-pass filter is similar to the passive high-pass filter. It is complementary to the active low-pass filter. The cutoff frequency is also same as the passive filter when the amplitude is 0.707 times the maximum. We had designed the active filters by providing input to the non-inverting terminal of the op-amp. Now we can design the active filters by providing the input at the inverting terminal of the op-amp. They are known as the inverting active low-pass filter. The voltage gain of the op-amp is however minus Rf by R1 and the output of the filter circuit is 180 degrees out of phase to the input. This is the inverting active high pass filter. Again the voltage gain is minus Rf by R1 and the output is 180 degrees out of phase to the input. So we implemented the high and the low pass filters using op-amps, and the limitations of passive filters are resolved by using op-amps in active filters. This was my ELP 101 project. Thank you.